Okay, in section 5.3.25, suppose Nate wins 35% of all staring contests. First question states that what is the probability that Nate wins 2 staring contests in a row? So we're going to begin by converting the percentage of staring events that Nate wins into a probability. So we're going to convert 35% into a decimal. So Nate wins staring contests with a probability of 0.35. Now, it is safe to assume that the outcomes of the probability experiment are independent, because there is no indication that Nate's winning one staring contest affects his winning any other staring contest. Now, since the outcomes are independent, we're going to use the multiplication rule for independent events. So, to find the probability that Nate wins 2 staring contests, it'll be the probability of Nate wins 2 staring contests is taking the probability of one contest times the probability of the second contest. And therefore, that probability was 35% of all of his staring contests. So it's 0.35 times 0.35, which gives 0.1225 as your result. Now for part B, it says, what is the probability that Nate wins 5 staring contests in a row? So therefore, it would be the probability that Nate wins 5 staring contests. So the probability that Nate wins 5 staring contests is equal to the probability of that event times the probability of that event again times the probability of that event the third time times the fourth time and the fifth time. And so therefore each event is 0.35. So we're going to take 0.35 times 0.35 times 0.35 times 0.35 times 0.35, which gives you 0.0053. Therefore, the probability that Nate wins 5 staring contests in a row is 0.0053. Now for part C, it says when events are independent, their complements are independent as well. We're going to use this result to determine the probability that Nate wins 5 staring contests in a row, but does not win 6 in a row. So again, we determined that the complement is equal to 1 minus the probability of that event. So we're going to determine that the probability that Nate does not win a staring contest by subtracting the probability that Nate wins a staring contest from 1. So the complement is taking 1 and subtracting 0.35, which is 0.65. And then we're going to use this probability as well as the result from part B to determine the probability that Nate wins 5 staring contests in a row but does not win 6 in a row. And then we're going to round to 4 decimal places. So we're going to take the value of 0.0053 from part B, and we're going to multiply by the complement, which is 0.65, which is equal to 0.0034. Thus, the probability that Nate wins 5 staring contests in a row, but does not win 6 in a row, is 0.0034.